Hi everyone, welcome to my session on how to observe your APIs with API Gateway and its plugins. My name is Bobur. I'm a developer advocate for Apache apisix. You can reach out to me on these following social channels regarding the sessions and feedback. If you have any additional questions, feel free to drop me. We can jump in call and discuss about the rest things, how you can observe APIs. So today we're gonna speak about APIs first, because the APIs nowadays is one of the important core component on building software, right? And then we will discuss what is API observability, and then I will give a short intro, recap how to say about API gateway, and how API gateway can be the central point for observation. We can also have a look this kind of section, and also you will learn what's the Apache apisix, and then how to use Apache apisix API gateway for you to observe your APIs. And we can also dive into some of the API observability three pillars like logging, tracing, and metrics, and learn how Apache apisix can provide this kind of the observability capability. And then at the end we'll have a small demo on the usage of this Apache apisix API gateway plugins for observability. So with that plan, let's get started. APIs, just three letters, right? But by now we are all familiar with this term. API, acronym for Application Programming Interface. We are living because in a very increasingly API-centric world. Every service used today either uses an API, or we can assume that it's an API itself, right? And API is becoming very central in building and delivering your services. Also, you know, the success of your services depends on the integrity, availability, and performance of your APIs. One of the tactics we usually apply is to retain all three concerns in this slide by continuously monitoring our APIs, right? And for example, we call it like API monitoring, right? Or traditionally this API monitoring, sure, I mean, it does help you to stay on the top of uptime, security, and the performance. However, it is limited because traditional monitoring focuses on tracking known unknowns. This means you already know what to measure, like requests per second or errors per second. And traditional API monitoring also lets you monitor the system health and on the other hand the performance, but cannot help you to identify and troubleshoot what's exactly causing the issues. On the other hand, observability involves analyzing unknown unknowns versus to known unknowns. When you imagine of the monitoring, as monitoring was about kind of measuring things, but you know how to predict them in advance, and whereas observability helps you to understand how and why those things happen. I mean, focus on what you cannot see, we call it unknowns, right? Observability is a cool thing to find out all the unknowns in the APIs. And what is the API observability? So we know observability means identifying unknowns, but API observability is all about making your API more observable. Instead of relying on predetermined metrics or monitoring or waiting for the failure to happen, API observability lets you dive into the unknowns of your APIs by observing how they work internally, and API observability also is ability to understand the system behavior and investigate the interactions between your application's components. It provides for your APIs like tracers, metrics, and loggers. So, and nowadays, API observability is already part of every API development, right? As it addresses many problems related to the API consistency, reliability, and ability to quickly iterate on new API features. When you design for full stack observability, you can get everything. You get everything you need, right, to find the issues, catch breaking changes. And API observability is not just used to troubleshoot engineering issues, but also it can also help to troubleshoot other business and security problems. As you can see in the next slide, each team needs API observability for the different purposes. Let's take for engineering. It provides clear definition on how to implement the APIs for the product managers to understand adoption and consumption of your APIs, or the line of businesses need to see the business value that your API is bringing in areas such as monetization, customer adoption, and new channel opportunities, like when you are establishing new integration or new business integration with other APIs, or the security teams to detect and protect from any API threats. And here the question arises, like, what is the easiest way to make our API observable? You can ask me, like, so there are many solutions, right, in our modern era. But one of the simplest quick solution that came into my mind right now is by using API gateway, right? Because API observability is a sort of data collection process. API gateway, you can think of just a framework to manage your applications in the API world. Of course, API gateway is further extended with countless built-in plugins to handle other cross-cutting concerns in addition to API observability, like concerns like authentication, security, authorization, traffic control, and many more. And most of observability platforms like Prometheus, Skywalking, OpenTelemetry, and others, they can easily integrate with Apache apisix, and then you can leverage these connectors to ingest the log data from your API gateways to the further down into the services that you have. And you can drive useful metrics from there, and you also gain a complete visibility into the usage. Also, you can manage the performance on the API gateway side and the security of your APIs in your own environment. I mean, because these most of the modern API gateway providers, they are very cloud native. You can use them in every public cloud or the private cloud or the hybrid clouds. So, what is the Apache apisix? It is part of Apache Software Foundation. You may already know the world's largest open source foundation, and I believe some of you are already part of this community. And nowadays, it's one of the fastest growing top projects of Apache Software Foundation. Like, you can think of Apache Kafka or Cassandra, Hadoop, Tomcat, and so on. Apache apisix provides custom plugin development, because we have some existing plugins and there is a possibility to create new plugins. You can write custom plugins in a programming language you are very familiar with, like Java, Python, Go, JavaScript, etc. And also there's another mechanism called plugins orchestration, where you can see the list of existing plugins on the Apache apisix UI dashboard, and you can easily drag and drop the plugins into the drawing board to combine them, right? And you define some conditions. For example, as you can see on this scenario, like we can start with authentication JWT, and then if authentication is successful, we can run another plugin by orchestrating and by putting them in a row, and also by collecting this couple of plugins together, you can create your own plugin. Bring our attention back to the observability. We said the core observability breaks down into 3 key areas, right? And like structured logs, metrics, and traces. Let's break down each pillar of this API observability and learn how Apache apisix plugins can simplify these tasks. Let's have a look at logging or logs. The logs are also easy to instrument and very trivial steps for API observability, right? Because each API event logged whenever some kind of API operation is invoked, and also you can collect some logs to debug your system. You can gain this analytic insights into your API activities. Also, they can be used to inspect API calls in real time for debugging, auditing, and record. Also, you can put some timestamps for each logs to identify events that happened over time. So, how did these logs managed by the API gateway, like apisix? It provides, for example, some logger plugins. Because the API gateway sits in the middle, right? Every request coming in this API gateway, and then this request sent over to the backend or upstream services. And in the middle means API gateway able to collect all the logs. Several logs, logging plugins available, as you can see in the picture, like HTTP logger, basic logger. We're gonna look also quickly today, or some other loggers you can see in the screen, like error logger, the Google Cloud logger, a Kafka logger that collects Kafka event logs and sends to the Kafka clusters. And for example, HTTP logger plugin is, as I said, capable of pushing log data requests to HTTP or HTTPS servers, and as in a JSON format, or it can also send these JSON files to the monitoring tools. We will look at these monitoring tools later on, or the next, for example, the second pillar of API observability, like metrics, analyzing metrics. Like metrics, just the numeric representation of data that collected over intervals of time. You can also aggregate these metrics into daily or weekly, or maybe monthly frequency, and run the queries against distributed systems like Elasticsearch. Or sometimes based on the metrics, you can trigger alerts to take any action later with action groups. Once API metrics are collected, you can track them with the metrics tracking tools such as Prometheus. For this, Apache apisix provides a Prometheus plugin. It's capable of fetching all the API metrics data, and you can show these metrics exported by the plugin on Grafana visually at the end. In the demo section I included, you will also see how to enable this Prometheus and HTTP logger plugin. And the last one, but not least one, is third observability pillar is tracing, or we call it sometimes distributed tracing. It allows you to understand the life of a request as it traverses your service networks allows you to answer questions like what service has this request touched, or how much latency was introduced by this API request. And for example, Zipkin, one of the tracer plugin Apache apisix provides. There are other plugins also. If you look at the Apache apisix official website, like skywalking, for example, and let's say Zipkin also open source project. It also provides some distributed tracing. You can enable this Apache Zipkin plugin to collect tracing and report them to the Zipkin collector based on the Zipkin API specification, or you can visualize it on the Zipkin UI. So with enough theoretical knowledge up to now, we can jump into the demo session about using these three plugins, HTTP Logger and Zipkin and Prometheus plugin. Together we apply this plugin for our existing ESP.NET Core Web API with apisix. We're gonna run a multi-container app with backend. I mean, in the backend we have product API. Let's say it has a single endpoint that gets all the product list. You can say we have this web online market that lists products on the main page, and this endpoint to get all these product information or with metadata. And then we have this database, just in-memory database. We run apisix and etcd together with the Docker Compose. And then we can configure this apisix upstream and route for the product API, because upstream and route very critical concepts in API gateway. Upstream means your backend service, not only one, it can be more backend services, right? And also route means just a set of rules based on which criteria to pass these requests to the responsible upstreams. We can also create this route also in this demo session, and then we will enable for this route HTTP Logger, Prometheus, and Zipkin plugins. All these code samples you can find on my repo apisix.net Docker on GitHub. You can check out the branch, API Observability branch, and you can also see the command line examples. On my case, I am using Docker desktop. I can show you here. As you can see, I have a couple of containers running along with Docker. Let's say we have apisix, Prometheus, Grafana, and the dashboard, apisix dashboard also up and running. And also I have some other like Zipkin and skywalking UI, some of the containers, but it's not important to run all these containers. You can just run, for example, the one that is in the repo. And now if you open the project, apisix.net Docker API Observability project, so you can see some folders here. The folders, I mean, like the apisix config files, apisix log files, where you can see all the apisix provided access logs or error logs. If something went wrong, you can dive into the logs and observe. And the next also I have this product API, just ASP.NET web project with a Docker file also to run this API. And then I have the Docker Compose file that runs all these images and creates the containers together. And the command line examples here for how to enable all the three the plugins. Okay, now we can start as a first step. We can start with creating upstream for our backend service. As you can see, I have prepared all this Carol command example in the code. For example, Apache apisix provides admin API to interact with all these upstreams. I mean, to manage all the upstreams or the routes or the services. You can always hit this admin panel, and for example, to create upstream or to create a route. In my case, I'm creating upstream with the product API as a backend service, and then by default we are using just the round robin algorithm. It doesn't matter if you don't put this, it will choose a round robin apisix. In our case, we have single node, and that's why we don't have to care about much the algorithm case. So, and then if you notice also each request we are sending with API key securely to talk to the admin API. So first thing first, let's create the first upstream. I will just copy this command line command example and then paste to my terminal and press enter. As you can see now, apisix returns out a successful response. It means everything is good, and everything is good, and then our upstream is created. So once we have upstream created, we can next we can create a route with HTTP logger plugin enabled. In Apache apisix, you can define the name for your route and also which HTTP method you would like to put as a matching criteria, or the URI, which URI path hit, and then this request sent to API stream, like kind of rules. And also you can list what kind of plugins you would like to enable for the given URI. In my case, I'm saying I would like to enable HTTP logger plugin, so that each time the request received, we log this request and send to this mock bin.org, just HTTP log server. Please collect the logs will be sent to the log server. And as you also see here, I am also showing this upstream ID. It means in the previous step we created upstream ID. We are just now referencing by its unique ID to this upstream. So let's copy this command and the pass to the terminal as well to enable HTTP logger plugin. If I bring this example, curl command example, and run this command, apisix returns successful response. And now we can validate if this plugin is working correctly. We can send request to our /API/products endpoint. This is our single endpoint that just simply returns us the product list. Like we have only 2 single products, but we might have more. And now some logs should be recorded and sent to this our mock server. Let's test it. If we go to this link and check our logs provided by apisix sent to this server. I can open my browser and navigate to mock bin. It means this is just mock server returning us this response, but if you do /logs, it should show us some kind of logs. Yeah, let me do /log maybe. Yes, now you can see some of the logs even a year ago sent, but if you scroll down and see the a few seconds ago some other logs sent by apisix, and here you can also observe what are the logs sent by apisix. All these log values you can also check on the website, what kind of logs usually apisix send to the server, etc. Now we demonstrated like simply how HTTP logger plugins works, right? And we created the upstream, and then we created a route. We also mapped a given route and upstream together, and we enabled also one plugin. The next maybe step we can test also the next plugin we have, let's say Prometheus plugin. This is also enabling Prometheus plugin is very similar to the step with HTTP logger plugin. You need to just define inside the plugins object, JSON object, the plugin Prometheus plugin name. So we are just making this Prometheus configuration as empty, but there are some of the attributes for Prometheus plugin you can also define. You can check them on the apisix website. Now I can run this curl command to enable the Prometheus plugin. I can just copy this command. Let me take this command and also pass to my terminal. If I run and press enter, all good. And now the Prometheus plugin should be enabled. And then if you return back to this example, for example, and run for let's say one more time, hit endpoint. I mean our API products endpoint. Let me hit one more time. As you can see, yeah, it's responding. But what about metrics? We should be able to see metrics, right? After we requested this endpoint, let's see what kind of metrics apisix is collecting. To get this metrics, you can navigate to /apisix/prometheus/metrics, but you can change this path under Prometheus config file. Sorry, I think this is here. This is below. For example, you can see the metrics path. You can define whatever metrics path you would like to, or some targets. In my case, I have one target in config, the apisix target. And if I run this metrics to get some metric comments, you can see lots of metrics returned by apisix, like apisix bandwidth, some etcd modifying indexes, and some latency information. And importantly, we have this apisix HTTP status metric available. That's actually our call when we did this /API products call, and as you can see, it's collecting some HTTP code information, and also route number, and raw node IP address, like from which node where this request sent. Also, we can visually see these metrics by going to, because we are by going to this localhost 9090 /targets or on your service /targets, because we are running also a Prometheus container. If you go to these targets, you can see I have apisix up and running, this Prometheus metrics and just the localhost metrics. And you can see by filtering apisix HTTP status only metrics, some of the graphs available with these matching URAs. Here's I mean how you see from on the Prometheus UI, but you can also see these metrics on Grafana, and this is the easiest way. Most of the developments teams now uses the Grafana as a dashboard. Now, if I navigate to another localhost port where a Grafana dashboard is running, I think it's in 3000. And here you can see that the Apache apisix the dashboard. whereas some data will be sent from Prometheus to the Grafana dashboard. But here is empty data because we need to configure configure some settings on the Apache apisix configuration file. So next, the last one, let's try to enable the zipkin plugin as a tracer and see how Apache apisix zipkin plugin can collect the trace information. So I can just get this similar configuration, plugin configuration for the zipkin. We can define the endpoint for this zipkin API. As you can see, I'm giving directly the IP address of my container. In real case, you should have the IP address of your server for these metric, the tracers, and the same we are using reference into upstream ID. I will copy this carol command and let's paste to the terminal and press enter. Now the zipkin plugin is enabled and we can test it by maybe sending some kind of API request once again and here, and then we can go to, for example, on the browser, open the zipkin server and see if we have some kind of tracers available by the apisix server name. Yeah, if you press run query, in 2 seconds the query should show the result, and as you can see there's one API request that we did this against API/product endpoint, and some here are the details, the tracing details. So of course here we have single service, but if you have a couple of services you can see how tracing works properly. So it was the last plugin for today. I would like to show you, but you can now ask the questions like why you are enabling single plugin at a given time instead of using all the plugins together. What if I would like to use 3 plugins together? Is it possible? Yes, of course it's possible. You can, for example, with apisix enable multiple plugins together. I have these examples also. Let's say you can run multiple plugins for the given role just by defining inside the plugins object all the plugins you would like to enable. For example, if I just copy this command and again this paste to the terminal, we just simply enabled 3 plugins together, like HTTP logger and the tracer and also the metrics, 3 plugins. So and also if you navigate to Apache apisix official website, let me bring the here on the browser. Here's apisix.apache.org. You can find some documentation under the plugin session, or you can take a look how to get started. There are some other observability plugins, as you can see, divided into by tracer and metrics loggers. Let's say you can find all the logger plugins here and all the metrics plugins like a Datadog, or the tracers like OpenTelemetry, also widely used as a tracer tool. So with that we are close to finish. Let me jump into my slides. And at the end, like as I mentioned earlier, on the top of observability plugins, you can use some of the plugins apisix provides, like for the traffic management, for example, you can use a limit count plugin, and feel free to check out other available plugins on the Apache apisix official website. Again, thank you a lot to join me today, and I hope you get some kind of knowledge about observability and API observability, and also how to make our API observable by using API gateways like open source Apache apisix. So now if you have any questions, feel free to ask. You can leave in the chat.